Okay, we're going back to Byte Magazine, and here is a group review section. This article is titled High Speed Memory Boards for ATs by Barry Nance. Upgrade your AT or clone's memory without downgrading performance. When you decide to upgrade the memory in your computer, makers of add-in memory boards for IBM PC ATs and comparables give you an impressive array of cards to choose from. These boards distinguish themselves by the size and type of RAM chips they use, the way the memory is accessed, expanded versus extended, the speed at which they operate, and the applications they support. I reviewed 15 add-in memory cards for ATs and compatibles to identify these differences. These boards have two things in common. They provide memory, expanded, extended, or both, beyond the 640K byte threshold, and they are designed to work at AT compatibles, not at, but in AT compatibles, running at speeds above 8 MHz. The testing for this review was performed with an Atronics International AT clone. Well, they got the spelling right, but not the capitalization of Atronics. So close. But this clone running at 12 MHz with 1 wait state and 1 megabyte of motherboard memory, 640K bytes of conventional memory, and 384K bytes of extended memory. The machine is an ordinary AT clone in all other respects, EGA card, parallel serial adapters, and fixed floppy disk controller. For software, Lotus 123 and the expanded memory device drivers supplied with each card were used for these boards supporting expanded memory. I used Microsoft's RAM drive.sys bundled with version 1.03 of Microsoft Windows. To test each board's extended memory, finally I used 2 CPU-intensive programs to test each board's effect on overall processor speeds. Tables 1 and 2 show the results of the evaluations, Table 1 for hardware and software characteristics, Table 2 for benchmark test results and price information. Currently, 3 kinds of memory are found in AT machines: conventional, expanded, and extended. Conventional memory is memory that DOS manages and in which applications programs run. It's limited to 640K bytes. Both the ROM, BIOS, and DOS are coded to use this memory in real mode. While in real mode, CPU addresses are limited to a length of 20 bits, giving an address range of 1 megabyte. The memory from the 640K byte boundary up to the 1 megabyte threshold is called system memory and is reserved for things like video display buffers and the ROM BIOS code itself. Expanded memory is still real mode memory, but it provides usable memory beyond the 640K byte threshold through a mechanism known as bank switching. A window in an unused portion of the system memory area is used to hold one segment or another of memory for an application to use. The standards and conventions for using this window properly are detailed in the document, and I typed it out exactly right here, but it's called the Lotus Intel Microsoft Expanded Memory Specification. Release 2 of Lotus 123 is an application that uses expanded memory. Xenix and OS2 are operating systems that do not use expanded memory. Enhanced Expanded Memory Specification, EEMS, is a memory specification designed by AST, Quadrom, and Ashton Tate. It also provides a bank-switched window through which specifically written software like QuarterDEX DESQ View can exceed the 640K byte barrier. Extended memory starts at the 1 megabyte boundary and extends as far as 16 megabytes. Since it takes a 24-bit address to access memory in this range, the 8286 CPU in an AT, or a clone of course, must be switched into what's called protected mode in order to use extended memory. Examples of applications that can switch into protected mode to use extended memory include Framework 2, AutoCAD, the V-Disk RAM disk, and Xenix. When looking for a memory board for your system, you should keep in mind a number of basic considerations. Table 1 shows the variations among the boards in the following areas. First, installed memory. This is the amount of memory on the board as shipped to byte from the manufacturer. Maximum memory. Many boards are capable of holding a maximum of 4 megabytes of RAM. The Limbo 1, RAM 2000, Memo Plus AT, and AT Mega Memory have a maximum capacity of 2 megabytes. You should also note that memory board manufacturers sometimes have a full line of memory board products. If you see an item here that seems like what you want, except that it doesn't hold enough memory, check with the manufacturer. The company may have a product that is similar but can put more RAM on the card. Monolithic Systems refers to its piggyback card for the Just RAM AT as a mezzanine card. The Just RAM AT card is the only piggybacked board tested that does not take up 2 slots. Chip type. RAM chip technology is advancing in quantum leaps. Some boards use chips and probably look familiar to you. A rectangular block of silicon with a double row of pins on the bottom with a capacity of 256K bytes or bits of memory. These are noted in Table 1 as 256K dual pin. This sort of chip is almost always an item that you can add to the board yourself. However, for space-saving reasons, some manufacturers use 256K bit chips that have a single row of pins and that stand on their side in a zigzag pattern. Finally, some manufacturers use 1 megabit chips on their memory boards. A row of 9 chips comes on a ribbon-sized card that has a single row of pins. The chips are installed by inserting the small card's pins into the memory card. Often a cradle supports a small 9-chip card, a SIMM, S-I-M-M, or single inline memory module in place. Ordinarily, the individual chips cannot be replaced on these 9-chip cards. Of course, the entire row/card is replaced or added as a unit. Now's a good time to take a break just to look at the pictures that they've been presenting while I read that section. The resolution isn't the greatest, but at least you get a good look. Might as well jump down to that table he's talking about, hardware and software characteristics. Pricing information was supplied by the manufacturers. So we have company, board, installed memory, and the maximum memory. That's nice when it's the same number. And that looks to be true for almost, 80% of them it looks like. This is really off. Profit systems. It's profitable to give your customers room to grow. They have the piggyback column, base price, price as tested, price with maximum memory, chip type, and then chip speed. So speaking of chip speed, that's the section we're on. This proved to be an elusive measure of RAM chip performance. While the memory chips used on the boards had stated ratings ranging from 80 nanoseconds to 150, some of the boards with supposedly lower or slower RAM actually perform better than boards with faster RAM. This paradox is cleared up when you recall that both the slow and the fast memory chips come from the same manufacturing process. The slower ones are rated that way because they fail certain tests during quality control. Faster chips are those that pass the tests. Putting faster rated chips into a machine will not cause it to run faster. Another consideration is that add-in memory is accessed via the bus, which can, and usually does, run at a different rate from that of the CPU. A 12 MHz CPU may access add-in memory at a bus speed of 8 MHz, for example. So now let's jump to the section called switches and jumpers. So whether you're an absolute neophyte at installing printed circuit boards or simply pressed for time, you appreciate having to set as few switches and jumpers on the memory card as possible. Some boards have no switches or jumpers, while the others have 2, 3, or 5 blocks of switches with various jumpers as well. And now we'll skip to the end, titled Memory as Commodity. Each board maker supplies a basic staple commodity for your AT or AT clone, As you have seen, there are significant differences in the way these boards provide that extra memory. When you decide to step back and leave the 640K byte barrier behind, you'll be prepared to choose a board that's right for you. As you make your buying decision, I suggest you keep the following factors in mind. 1. You never have enough memory. A board that holds less memory will not satisfy your needs for as long as you expect it will. 2. You never have too many slots. A board whose piggyback card slops over into the next slot will someday be thought of as a slot stealer. Number 3, you never have enough processing speed. A board whose design or emulation of EMS in software degrades your CPU rate will have you muttering while you stare at the screen, waiting for some application to finish its job. And 4, you can never say that you've purchased your last software package. If you say that you don't need EMS, it's Murphy's Law that your next application will proudly state on the label that it uses EMS to give you extra workspace. Don't necessarily buy the most expensive board. On the other hand, don't shortchange yourself. Try to plan for your needs over the long term and then add a fudge factor as a contingency against that as yet unannounced application that is exactly what you need but requires OS2 and X megabytes of memory.